So now let's take a look at a word problem. This one has to do with an exponential equation still. This says the number of victims of a flu epidemic is increasing at a rate of 7.5% per week. And you'll notice that I bolded per week here. If 20,000 persons are currently infected, find in how many days we can expect 45,000 to have the flu. Okay, so a couple important things here is, first of all, the thing that I bolded here, you'll notice that our units aren't matching up, so we've got to be careful with units and how we calculate this. Now, when you see y sub 0 always means your initial amount, how many you started with. So in this case, our y sub 0 is our initial amount of 20,000. Our future value of y is how much we ended up with, which was 45,000. Our t is unknown, but t is going to be in weeks when we calculate it. So to answer the question, we're going to have to figure out how many days, we're going to have to multiply by 7. So we just got to be careful there. So our equation tells us we have 45,000 equals 20,000 e to the 0.075t. So in order to solve this exponential equation, and this is an exponential equation because we do have some number, e, raised to a variable power. In order to solve this exponential equation, we want to get the exponential part by itself. So we need to get rid of the 20,000. Now be careful, one of the tempting things to do here is to subtract 20,000 from both sides. Subtraction undoes addition. This was multiplication. So we need to use division to undo the multiplication. And so 45,000 divided by 20,000, the thousands divide out, and then really 5 goes into each of those. So it really just goes down to 9/4 without too much math at all. Now to undo e to a power, we have an obvious choice of natural log, because natural log, remember, is log base e, so it'll actually directly undo this. So the natural log undoes e to a power, and that gives us the natural log of 9/4 equals 0.075t. So to get the t by itself, we just need to divide both sides by 0.075. So now I'm going to get out my calculator, and I'm going to have the natural log of 9/4 on the top and 0.075 on the bottom. And I get this number 10.81 something or other. But remember that this is measured in weeks. So I need to multiply this by 7 to figure out how many days, because that's what I was asked about. So just to be a little bit picky here, we're looking at about 76 days is the answer we're looking for.